completed his BVAC and AH with gold medal from Ranchi Veterinary College, Jharkhand in 1990, MBSc in LPM from IVRI Bareilly Ijatnagar in 2001, and PhD LPM from Gadwasu, Ludhiana, Punjab in 2011. He completed a postgraduate diploma in technology management in agriculture from the University of Hyderabad in 2018. Sir has joined as Dean of the College of Veterinary Sciences and Animal Sciences, Kisanganj on November 24, 2022. Kisanganj is the second veterinary college of Bihar under the aegis of Bihar Animal Sciences University, Patna. Before joining Basu, Patna, Sir worked in different capacities in SAUs and ICR. He started his professional career as a junior scientist from assistant professor at Squash, Kashmir, Srinagar from May to December 2002 and was posted at cattle breeding farm, Manaspal, Kashmir. He worked as assistant professor in LPM at Gadwasu, Ludhiana from December 2002 to July 2014. He served as a senior scientist at ICAR Central Avian Research Institute, Ijatnagar, Bareilly from July 2014 to July 2017 and acted as the principal scientist from July 2017 to November 2022. He has more than 23 years experience in teaching, research, innovation, and extension. Sir has authored more than 340 publications, including 71 research articles in the Journal of National and International Repute, 17 books, 19 practical manuals, 39 book chapters, 51 popular articles, 5 technical bulletins, 27 lead papers, 55 research abstracts, 53 MUs. Registration of 4 native chicken varieties and 3 patents are in the pipeline. He received 32 awards, including gold medals, JRF, SRF, ARS, Young Scientist, Best Paper, Best Poster awards. He was awarded the Fellow of National of Animal Production and Management by ISAPM in 2019. He has guided 7 MBAC and 6 PhD students as a major advisor. He has handled 19 research projects, including PI in 10 projects. He managed various livestock farms like native chicken, goat, pig, rabbit, laboratory animals for more than 20 years and has developed a package of practices as well as the standard operating procedures for almost every livestock species, including poultry. One of the notable areas of work was the management of poultry and piggery waste. He has developed DAC technology for all-weather biogas production exclusively from both layer and broiler types of poultry excreta. He has also developed remarkable technologies for the production of compost and vermicompost from both broiler and rare types of poultry excreta. Simultaneously, he has also standardized the technologies for biogas, compost, and vermicompost production from piggery excreta. He has been involved in the conservation and maintenance of beetle goats at Gadwasu, Ludhiana, a native chicken at ICAR Carry, Ijatnagar, Bareilly. Native chicken varieties such as Asil Pilla, Asil Kagar, Kadaknath, Nicovari, Ankleshwar, Colored Naked Neck, Colored Frizzle, Silky, and Carry Red were conserved and utilized for the development of various native chicken varieties from family of backyard poultry production systems. Some notable varieties are the Kyari Prabal, Kyari Saloni, Kyari Giri, Kyari Dhaval, and Kyari Nira Safed. He was actively involved in the propagation and distribution of native chicken breeds and varieties like Kyari Nirvik, Kyari Shama, Upkari, Hitkari, Ashil Pilla, Ashil Kagar, Kadaknath, Nicovari, Ankleshwar, Color Naked Neck, Colored Frizzle, Silky, and Kyari Red throughout the country. He was actively involved in the development of a natural integrated backyard poultry farming model, namely Girigram Takniki Park on 1 acre land at ICR Carry, Ijatnagar for doubling the farmer's income. While working under the NAIT project in the Hoshiarpur district of Punjab, he developed low-cost portable bamboo-made poultry cages. He standardized the concept of broiler goat production under stall-fed conditions. For improving the welfare of the goats under stall-fed conditions, he designed the linear and hexagonal feeders for goats. He is also actively involved in the propagation and transfer of the technologies about commercial piggery and rabbit farming. Sir has worked with various laboratory animals and has acted as the member secretary of AIEC for about 8 years. With so many accolades with the guest with us, we welcome you, sir, for the formal presentation. Thank you.
Thank you. Thank you very much. So good morning to all the participants. And I hope that within this 1 hour, we will try to discuss some of the effective utilization of waste in integrated farming system for doubling the farmers' income. Here, I will discuss about the principles and some of the procedures. However,
माइक भी बंद कर दे, दोनों बंद कर.
excuse me,
कैमरा और बंद कर. अरे
whether I am audible?
बंद कर रहा.
Yes, sir. Yes, sir.
और दूसरा बंद कर माइक.
I am getting
हाँ.
background sound.
Just a minute, sir.
Hmm.
Dr. Prabal has muted. Okay, sir. Continue, sir, please. Sorry for the interruption.
Okay. So within this 1 hour, I will try to discuss principles, and those who is having interested in waste management for this integrated farming system, you can go through in detail. Actually, as I have been introduced, I was specialized in livestock production management, but due to curiosity, I have started work in waste management. Because in integrated farming system, one of the major input is waste. But we are using waste in direct context. Means directly we are utilizing waste of one farm in the other farm. Means output of one farm is becoming input for other farm. In this form only we are utilizing the waste. But here, my concept is a little bit different. I prefer to first convert the waste in some value-added products, and that remains shall be utilized for integrated farming system, or some innovative product may be produced from those waste for utilization in integrated farming system, because the ecosystem of integrated farming system has a bearing capacity of nitrogen. If it will be more than that, productivity will be go down due to pollution, due to more carbon, more no nitrogen. So I will discuss those innovative ideas, how we can use further in integrated farming system after getting some product from waste. And in beginning only, I want to tell you that if we shift towards waste management in any farming system, sustainability of farm increases to many times, not only twice. It may go up to 5 times. So lots of scope is there, but unfortunately, only few farmers are getting aware of this waste, and they are going towards value addition of waste before utilizing in integrated farming system. So with this introduction, I want to introduce waste. Actually, nowadays nothing is waste in any farming system. If we use the term waste, this is due to our lack of knowledge. Nothing is waste. All can be utilized. However, the science has defined waste as anything that is no longer useful and need to be disposed of. But as I am telling you, nothing is waste. That is based on one principle, law of conservation of energy. And due to that, we have introduced the term zero waste concept. Actually, everyone is from the science background, and we know that energy can't be created nor be destroyed. Only it can be transformed. So to whom we are calling the waste, basically that is a transformed form of any active energy ingredient. For example, you can see this photograph. If a chicken is grown to the marketable age from a chick, it is consuming about 2.5 to 2.75 kg or 3.5 kg feed. Out of that 3.5 kg feed, we are getting broilers of around 2 kg. So where gone that 1.5 kg? That was an energy form that transformed in excreta or in feather or in eggshell. That is a transformed form of energy. So that is not waste. Only we are not able to utilize that energy, transformed energy. That's why we are calling it waste, because otherwise it is having same potential as crude feed to get energy from that, whatever we call it waste. So when we are applying zero waste concept, we should now not use term waste. Otherwise, in future, we may push towards energy crisis, as whatever waste we are calling, that is a transformed form of energy. So to protect our future generation from energy crisis, now we have to boast on the zero waste concept, and whatever animal waste material we are recognizing as excreta or as bedding material or as mortality, those all could be effectively utilized for value addition first and then for integrated farming system. I'm not going to discuss anything directly about integrated farming system. I'm not going to introduce the concept of fish cum pig farming, fish cum poultry farming. No, you all know. Only innovations, what we can do innovative to waste so that the productivity could increase in clean manner. Because just now I have introduced that when in fish pond we are putting the excreta of animal, pig or poultry, whatever, there is bearing capacity, and if beyond that it is not clean, pond is not clean. So we want to avoid that situation, and we want to use clean production of through waste in integrated farming system. And indirectly, I'm going to discuss some value-added products from waste for utilization under integrated farming system. So with this background, everyone is known from the current livestock status of the country, and everyone knows that our total livestock is around 535 million as per 20th livestock census, and simultaneously our poultry population is also around 851 million. And this population is going to produce lots of excreta or waste. And you can calculate, if we are knowing the average manure production from a unit type of livestock. For example, finishing pig is producing around 7 kg, and I have narrated everywhere, broiler, layer, every bird is producing to some amount of excreta. And if we go to the chemical composition of this excreta from different farm animal, we will get a very peculiar fact. And from here, we could get the answer why we are not able to utilize the waste to the extent as we wish. Here I want to clarify that there is no problem in utilization of cattle waste. Cattle waste is being utilized from centuries, either in our household in form of some material of cleaning, or in form of burning, or in form of gobar gas, or many types. It is very clear, but for other species, it is very difficult to use. That's why we have to think for utilization of those waste which can't be directly used. And answer is hidden in this slide. Why we are not able to utilize other waste besides cattle for any value addition. So if we can see the column, you can see I have listed cow, buffalo, horse, sheep, camel, goat, piggery, and poultry. Out of that, piggery and poultry is monogastric animal, and Horse is also monogastric animal, but other species are either ruminant or pseudo-ruminant. And you can see whatever I have arranged, dry matter is increasing from cow to poultry. Poultry is having maximum dry matter in the excreta, and nitrogen is also increasing as per the arrangement. You can see here the poultry is having highest nitrogen, followed by piggery, and cow is having optimum. If we go through the crude fiber, which is a source of carbon, and we use some formula for conversion of crude fiber to carbon, and for the waste utilization, carbon nitrogen ratio is the most important factor. Any waste present in your area, if you want to utilize, you have to use carbon nitrogen ratio. And you can see the peculiarity. Cow is having highest carbon nitrogen ratio, and poultry, piggery is having lowest carbon nitrogen ratio. Exception is goat, I agree. However, in monogastrics, lesser carbon nitrogen ratio is because they are not fiber eaters, they are not fodder eaters, they are using only grain eaters. So the animal who are fodder eaters, they are having more carbon nitrogen ratio, and animals who are grain eaters, they are having less carbon nitrogen ratio. And any species whose carbon nitrogen ratio falls between 20 to 25 can be utilized directly for any value addition in waste. Cow and buffalo, though it is ranging nearby 20, however, since they are having more fibers, so microbes are growing easily in the cattle or buffalo dung due to dilution and fiber present. So from centuries, we are utilizing the waste of cattle and buffalo. But for other species, still there is a question how to utilize it. And if we will use it directly in integrated farming system, there will be more nitrogen in the pond system or in other system, and it will be pollution rather than production. So with this background, we have to think how to use the waste of other species in integrated farming system, because integrated farming system include agriculture also, integrated farming system include fisheries also. And if fish component or agriculture component we will take, if we will use more nitrogen, our crops will be dried up due to more nitrogen, because nitrogen get convert in ammonia, ammonia get convert in ammonium hydroxide through moisture reaction, and ammonium hydroxide having caustic action on plants. So this way agriculture crop is having harmful effect due to use of those waste who is having lower carbon nitrogen ratio. Or in fish pond also, it will be source of pollution due to more nitrogen, because more nitrogen is very much detrimental for the fish also. So if we see the gross value of waste, our BAHS figure also shows only the value of dung. They have never taken into consideration the value of other excreta. Otherwise, the all excreta of all the livestock and poultry is much more valuable than the dung. And you can see our main product is milk and meat from livestock, and dung comes from third position. So see the value of dung or excreta. It is even more than egg. Whatever we are getting output from egg, that from that dung output is far higher. And think, if we can use excreta of other livestock, then what will the figure? It may give competition to meat group output also. So lots of potential is there. Only we have to harness this potential, and our scientists who are working in integrated farming system or in similar farming system must disseminate this kind of concepts among farmers, so that they could be directly benefited for better sustainability of their farms. One more thing, if some untoward incidences occurred at farm, waste will be the only value which could save that farms during that incidents. So waste value addition is now becoming better tool for more or sustainable livestock farm income. So I request all the participants to grab this kind of concept and disseminate it among the farmers so that they could get better earnings from their existing units. I'm showing here photograph of poultry, but technological advancement is prevalent in almost all livestock and poultry farm. Double, triple tiered housing system or intensive housing system is nowadays a common principle of farming, from where solid and liquid wastes are being produced regularly. And we know that whatever waste we are producing, they are having environmental as well as sustainability issue. Environmental issue in form of, just now I have discussed, for those species who is having lower carbon nitrogen ratio, burning of crops is a common problem due to higher nitrogen or lesser carbon nitrogen ratio. Otherwise, it could have been better produced if carbon nitrogen ratio could have been put in proper ratio. So this is a big problem. Environmental issues are the other burning outcome from inefficient utilization of waste, which include contamination of groundwater and further contamination through nitrate due to land spreading of many kind of wastes and materials, mortality. Eutrophication of water bodies is a common problem, and further destruction of ecosystem, aquatic ecosystem. Spread of pathogens, air pollution, insect problem, greenhouse gas. These are the common environmental issues which we are addressing without addressing the utilization of waste. This is a confusing situation. What we want to manage, how we can manage. We are not able to prepare a concrete plan to tackle the environmental issues because no one is talking for the utilization of waste of unfamiliar species, especially those who are having lesser carbon nitrogen ratio. Health issue is another problem. There is one research article published in 1986 in UK, and they are telling that nitrate contamination of groundwater is a common problem due to waste in our country also. And higher level of drinking nitrate in drinking water resulting in blue baby syndrome in all the industrial area and the area where we are performing the livestock farming. That is also known as methemoglobinemia. Cancer is a common problem. We are giving blame to other ingredients, other chemicals, pesticides, herbicides also, but nitrate is one of the reasons for cancer also. Who knows, in industrial area cancer may be due to this. We have to sort out in India also. Respiratory illness, everyone know ammonia, if more than 20 ppm. Post respiratory stress, 25 ppm, start stress increasing. And if you go up to 40, 50, pneumonia-like symptoms immediately erupts. So abortion in livestock also has been reported. So much problems are there from waste, but we are not tackling it to the. So as I was talking, value addition and that its utilization in integrated farming system is need of the hour, and value addition of cow and buffalo dung is a common practice. There is no question about that. But still, we can disseminate this concept to the farmers that if they are managing carbon nitrogen ratio properly, If they are managing moisture, carbon nitrogen ratio in the range of 20 to 25 and moisture in the range of 40 to 50% in any species, you can do miracles and you can produce any kind of value-added waste, including compost, vermicompost, organic fertilizer, biogas, anything, even your powder cake, anything you can produce. Even in pharmaceuticals nowadays, though farmers can't use it, and it is having no relation with integrated farming system. But who knows, some of the entrepreneur may start producing this kind of product from pertaining to pharmaceuticals for better sustainability of his farm. We are producing Panchgavya, we are producing phenyl, biopaint, mosquito repellent, biomedication reagent, even microbial enzymes we are producing. Lots of things are coming from cow and buffalo dungs. Urine also getting many things. We all know nowadays algal production for as a source of protein, duckweed, azolla, common outcome from this cow dung and urine. It can be usually utilized. Lots of products you can see now also. So these are aiding the economics. You can see here, lots of potential is there. Even it is better than their main product, milk or whatever, or it is having better sustainability. As per estimate, we have calculated that 30 to 40% more income is possible if we are going from waste value-added production in dairy farming. But what about other species? If now we talk about integrated farming, it's having lots of potential in agronomy because the output of any livestock farm or poultry farm may be input for agronomical practices in form of organic fertilizer, powder pot, or composting, vermicomposting, vermiwash. These concepts can be introduced at farm level or better value addition. I'm telling you, 40% or even more, up to 50% more income generation is possible through integration of waste. Even in livestock, as a dietary resource also we can use waste, especially in ruminants, because their nitrogen can be converted in single cell protein. So there can be used from monogastric animal, whatever waste is being produced, which having more nitrogen, that can be used as a dietary input for ruminants whose age is more than 6 months. But even after so much year of independence, we are not able to develop that kind of technology except in laboratories. It is not common in field level. It should have been. We are using fish feed, poultry from poultry waste, or we are producing azolla mushroom from these wastes. That's good. But still lots of waste is unutilized. And we are facing the problem of feed scarcity. This can be a probable solution if technology could have been standardized in a better way in India, because India is developing like anything, and we can have, so our participants can think on this also. From laboratory, if they are practicing this, they can go in field also for its practical utility and think for this. Similarly, here there is double benefit in integration. Suppose we are producing energy from waste, the slurry can still be used in the same way as we are using the crude excreta for any kind of integrated farming like fish cum duck, fish cum poultry, fish cum piggery, fish cum goat, any system. So there is double benefit if we are producing biomass in form of biogas or biodiesel or gasification we are getting energy, as well as whatever byproduct is there that can be used for integrated farming system for the feeding resources of other species. of plant or animal under integration. Everyone knows the concept of incineration, but it can't be used as farmer's labor. From here, there should be government effort to use incinerator based on briquettes composed from excreta of those animals who is having lesser carbon nitrogen ratio, because they are more threatful to our environment, our aquatic system, and we are throwing a still. Whatever digestive problem, whatever health problem we are suffering, who knows that is due to those kind of excreta which we are not considering. So government may take effort for incinerator, and whatever excreta briquettes are there, they are having energy value half of the coal. So still there is lots of possibility. We can use that, and they will be used to run the turbines. Thermal power plant can easily be established in area where livestock farming is a common practice. So we have to think about that. Even gasification, where there is incomplete combustion of excreta in limited oxygen environment, and there is production of energy we can use for thermal power plant for running the thermal turbines. But again, the government has to take effort. Farmer can't do it for gasification. Farmer can go for rendering. Lots of work has been done in India now on rendering. And many scientists, one notable scientist is there, Dr. John Abraham. You can see the photograph. He has developed a very good technology for biodiesel and biofertilizer. Mortalities, which is thrown out, who can spread the disease also, can easily be used for biodiesel production with equal knocking value as natural diesel. And see the future. This is the future technology. Lots of mortalities are there, especially during any outbreak. Why not we could use that for biodiesel production? Simple dry batch rendering process is there, followed by esterification using acid catalyst. We are getting biodiesel as well as glycerol also. Glycerol is having good commercial value. And you can see the cost of production. Production cost of biodiesel is 36 rupees per liter in 2021 when Dr. John has been granted patent for the same. Now it may be 2-3 rupees or more. You can compare, it is having less than half production cost. And this is the future generation. And whatever biofertilizer will produce, that may be used in integration of agronomic practices with equal outcome. And it is a type of organic farming. So we have to think for this kind of technologies for integrating our farms through biofertilizer and value addition of mortalities in form of biodiesel. And you can see we can get 87% biodiesel and 13% glycerol from whatever fatty component is coming out from any mortality of any species. So another technology everyone knows, biogas production. Age-old technologies we are using from more than 200 years or even more. Mars gas it is called. Everyone knows methane is the main component. But still, in India, we succeeded only in production of biogas from cattle or buffalo cow dung, or production of biogas from the dung and poultry piggery excreta mixed. But think for those farmers who are poultry producer, piggery producer, equine stud producer, from where they will produce, because there is no technology. We concentrated on this aspect because there is no problem in biogas production from cow dung or buffalo dung. So we have started concentrating on poultry and piggery as well as other wastes who are having lower carbon nitrogen ratio. Same technology we have used, principle of same technology, whatever biogas production principle is there, either we use floating drum biogas plant or fixed dome biogas plant. The principle is same. We have used that principle for production of biogas through the established principle of hydrolysis, acetogenesis, and we are getting methane along with some of impurities which need to be purified. Before coming to the main topic, for biogas production from poultry or piggery or other excreta, which having low in carbon nitrogen ratio, we should first decide whether there is biogas production potential from the waste which is produced from our livestock. You can see biogas production potential is more from the crude fats and less from the animal component, but it is sufficient for a livestock. Though bars are very lower, but it is sufficient. 25 kg of cow dung is producing almost half kg of biogas equivalent to LPG after purification. That is 1 cubic meter of biogas. But only 12 kg of poultry, 12 to 14 kg or 18 kg of piggery excreta is producing similar quantity of biogas, that is 1 cubic meter weighing around half kg of LPG after purification. So this is the potential, but we are not thinking on that aspect. And you can see there lots of production potential in many states where biogas production is almost nil. Andaman, Nicobar, Dadar, Haveli, Goa. So lots of potential is there. We have to think, the area where temperate climate is there microbes for biogas is not multiplying to the extent we need. So in the states like Jammu Kashmir, where temperature remains very low, it's very difficult. But the scientists from there, they may act on this, because this is every challenge has opportunity. If it is challenge, lots of opportunity will come. We may go through this kind of technology development for our farmers for their better sustainability. When we have started working, we worked on what is the optimum criteria for biogas production. And then we have compared with cow dung where we are lagging behind. And we have standardized those lacunas for better biogas production from piggery and poultry excreta on the pattern of cow dung. And we got that carbon nitrogen ratio and pH was the main factor which posing problem in biogas production. And through in vitro standardization and its utilization in our own developed biogas digesters, we are able to produce good quantity of biogas equivalenting to 14 kg of poultry excreta for 1 cubic meter biogas, or 18 kg excreta for 1 cubic meter from piggery excreta, in comparison to 25 kg cow dung for 1 cubic biogas production. So these species are having efficient outputs for biogas production, and whatever slurry is there, that can be easily used in agronomic practices without any caustic effect on plant materials, because whatever nitrogen, excess nitrogen was there, or whatever carbon was there, whatever ammonium hydroxide production mechanism was there, they all get broken up, and we can use that spent slurry directly in agronomic practices or in fishery integration farming system. So this is the beauty of these technologies. We are getting value-added product. And when we have standardized this technology, it was very much in news throughout the country. And we have also tried to purify it. Lots of technologies we have developed. And we have got 4 to 5 times value addition from this biogas technology due to utilization of slurry in integrated farming system, along with biogas production, and whatever excess biogas we produced that was used for electricity generation for running the own farms. See, lots of potential is there for biogas to produce electricity. 1 cubic meter biogas produces around 1.25 unit of electricity. This is the beauty. So whatever excess biogas is there, we can run the biogas gensets. Special gensets are coming. And we may make our farm free from the electricity board electricity. No need to purchase. And this is the indirect saving to the farmers. So in this way, our farmers can get 4 to 5 times value addition or economic output from those same farm. So we have to sensitize our farmers for this kind of, and this is the economics. If I have calculated for birds, if anyone is having a bird of 50,000 capacity, their net annual income comes around 32 lakh after integrating everything. And if he is taking loan, he can pay it in within 8 months. So much scope is there, but still our country has not make any kind of way to adopt this at farmers' field. Similarly, from piggery also, that technology we have standardized and we have produced biogas very easily. Another technology is composting. We can't use all the excreta in the integrated farming system. So what is the other way? Either throw it and pollute our environment, pollute our aquatic ecosystem, or utilize it for production of compost and vermicompost or organic farming system. Again, a clean farming system for our country, which is having lots of export avenues. And beauty of this composting is mortalities can also be used for composting in same way. Since in composting temperature goes beyond 80 degrees C and that remain for one to 1.5 months, no remnants of bone even present in composting of mortality. So if any farmer is unable to utilize the technique of bio-rendering, he can go for composting, and mortality simultaneously can be used for composting. So the throwing of dead animals or birds, which is posing lots of other problems, can be mitigated very easily. So composting can be used. And again here utilizing principle is carbon nitrogen ratio in the range of 25:1 and moisture 40 to 50%, maximum to 60%. Size, height of the bean around 3 feet, and time period is around 2.5 months, and you will get a good quality of compost, which can easily be used in other agronomic practices. And to raise the carbon, see, cow dung can't be used for composting because they are having other value and can be used for production of other value-added products. But those animals who are monogastric, having lower carbon nitrogen ratio, their carbon nitrogen ratio can be elevated to 25:1 by using these straws of paddy or wheat, which is being burned by the farmers, especially in Punjab and Haryana or other part of country. Nowadays, there is little bit awareness. They are also producing value-added product from these straws, but still composting may be the best option for utilization of these straws with the excreta of monogastric animals, which is being produced in lots of million ton. Only poultry is producing 28 to 30 million metric ton per annum. Piggery is producing similar. So see the scope. If we are not composting the carcasses, whether poultry or other, then we are going for burial, incineration or rendering. But still it is questionable why we have not used burial. If we are using, it is having pollution threat for our water table. If we are incinerating, There is pollution threat for our air. Rendering, lots of input required and government support is required. So composting is a better option for carcasses also. And out of aerobic and anaerobic composting, aerobic composting is having good compost output than anaerobic composting. And it is a very simple technique where we mix the excrete or poultry waste, waste or piggery waste or other waste which is having lower carbon nitrogen ratio with some agronomic waste like sawdust, leaves, grasses, straws. To make it carbon nitrogen ratio 25:1, we put some water, make moisture 40 to 60%, and within 2.5 months, very good quality composting you produce. And beauty of this compost is that whatever harmful bacteria is there, they all get destroyed. Whatever E. coli, whatever salmonella, or whatever other harmful pathogenic bacteria or pathogens are there, parasites are there, they all get destroyed as temperature increased to the level of 80 degrees Celsius, and that too remain for 30 to 45 days. So this is a good technique to make our environment clean from the pathogens spreaded due to waste, livestock waste. And it is having good agronomic. This kind of compost is having more than 80% germination potential. And this kind of composting bins can be used. Only basic concept is air should be passed and it should be installed on some hard floor. So big composting heaps are being also produced in Western countries, and where they are producing the waste in tons. Even this kind of ready composter are also nowadays prepared for getting compost in shorter period, 15 to 20 days time. So another technology is vermicomposting. And beauty of vermicomposting is that besides vermicompost or organic farming system, the earthworms may be used for backyard poultry production. We have used at Central Avian Research in Ijatnagar, Bareilly, where we have established a Girigram Technique Park in 2021 or 2020, where the birds were in 1 acre land, and we are using the vermicomposting both for feeding the birds with the earthworm as well as selling the vermicompost at the rate of ₹8 per kg. In market, its cost is more. So see the beauty. Money as well as egg, organic egg, which is having again more price value in market. So vermicomposting technique is known to everyone. Only basic difference between vermicompost and composting is that here earthworm is being put with height is only up to 1 feet in vermicomposting, whereas height is up to 3 feet in composting. And generally at CRI we are using a very branded earthworm Jagopal. There is in wide range of temperature ranging from 2 to 46 degrees C, and that's why it is very much popular, developed at IVRI Ijatnagar. And the technologies we can learn by using various type of brick made pits or poly pits, whatever, with standard size of height maximum up to 1 feet, width maximum up to 1 meter or 90 centimeter. So this kind of concepts we can use pit method or windrow method, and we give this is the finished vermicompost which can be shipped, and we have produced vermicompost from poultry as well as piggery etc. also, and that can be shipped this in this way, and they can be used for integration with agronomic crops. If we are using for field crops, they may be for 5 to the quantity may be 5 to 6 ton vermicompost per hectare land. Vegetables 10 to 12 ton per hectare land. flowering plant in floriculture 100 to 200 gram per square feet area, and fruit trees 5 to 10 kg per tree. So this is the beauty. And we have calculated for broiler birds additional 5 rupees 60 paise gain may become from per bird, besides the selling of broiler birds, which may range between 20 to 30. So this is the beauty. If 25% income is from this vermicomposting, so why not we can use? We can tell our farmers, and you see, any farmer who is having 50,000 layer birds, this is for layers, their net income may goes up to 17.6 lakh per annum. So this is the beauty. Even same vermicompost may be used for vermiwash also, which is a layering technology where we make layer. You can see the lowermost layer is of bricks. After that, we put soil. Then we put cow dung or poultry excreta. Then we put vermi earthworms, and we put drip water. Whatever water we are putting drip 4 to 5 liter in drop wise, that get collected in vermiwash in the form of coffee color, and they can be diluted up to 5 to 10 times for using leafy vegetables, where it not only used as act as fertilizer, but also act as natural herbicide and pesticide. See the beauty of vermiwash. And its cost is 25 to 50 rupees per liter. So see the beauty. We can use this technology for the farmers. Even the heavy metals contaminated water can be filtered by candles made from the excreta of poultry. The charcoal is being formed from that excreta, and we can make candles for clearing the heavy metals. So this is another scope. I want to tell you innovative integration of waste in Girigram Takniki Park, which was in 1 acre land, and we have developed this kind of vermi beds. On left side you can see, and these are low cost houses, 20,000 rupees for 300 birds. And there we are using agronomic practices also. Whatever excreta, surplus excreta there, that is used for agronomic practices, and the birds are being fed to plant material as well as vermi compost produced earthworms, where we are getting up to 57% crude protein on dry matter basis. See, one earthworm is sufficient for around 6 gram protein for the birds. 6 gram can be fed through this 1 or 2 earthworm, depending on size. See the beauty of this technology. Even we are producing maggots from the excreta of this poultry there, or even cow dung. And 2 types of maggots we are getting. One black soldier fly maggots and other housefly, common housefly maggots. And they are having crude protein about 44%. And we are producing these maggots through these wastage water tanks. We have developed this technology, and one tank is producing around 4 to 5 kg maggots daily. And if 20 gram can be fed to the birds, they are easily getting 7 to 8 gram protein. See, earthworm and this can fulfill half of the protein requirement of the birds in the backyard system. So this is the beauty of integration through value addition. So these kind of technologies can be disseminated to the farmers. Even slaughterhouse waste can be used for composting, organic fertilization, or rendering, whatever we have discussed. But never proliferate burial, incineration, rendering. Even poultry feathers can be used for production of biodegradable plastic technical textiles. So this kind of technology is the future technology. Actually, byproducts can be used for making pet biscuits or other biscuits for feeding animals. So I think I have able to discuss many technologies who can be first value added, produce in waste, and then utilized in integrated farming system. And if we optimize our waste management, there is a lot of scope for livestock and societal well-being vis-a-vis their welfare of human society. And simultaneously, our farmers is getting quality product and much more economic gain, which is the need of hour. So I hope that I could able to sensitize you to use the waste in the manner what is the need of hour. Thank you very much.
Okay, thank you, sir. Thank you for your lecture. And right now the session is open for questions.